Hi, I am Arib. You are watching my YouTube channel. Different types of power transformers. Power transformers can be classified based on core and winding construction, turns ratio, phases, and core material. Core and winding construction and arrangement. Ferrite type transformers. Ferrite type transformers have the core arranged like spokes of a wheel. They have distributed magnetic circuits and contain more than two independent magnetic circuits. Cor type transformers. In core type transformers, the primary and secondary windings surround the core. The core of these transformers is constructed by joining two L-shaped steel strips and stacking them to form the layer. To avoid high reluctance at the joints, the strips are arranged such that continuous joints are eliminated. The limbs and the yoke carry the whole of the flux. Shell-type transformers. In shell-type transformers, the core surrounds the primary and secondary windings. The core of these transformers is constructed by joining E-shaped and I-shaped steel strips and stacking them to form the layer. The central limb carries the whole of the magnetic flux, and the side limbs carry half of the flux. Isolation transformers. Isolation transformers have a turns ratio equal to 1, which means the number of turns in the primary and secondary windings is equal. They are used to isolate the load from the power source while supplying alternating currents. They protect the electrical device, operation, and persons from electrical noise, shock, and damage. They are commonly used in computers, measurement devices, industrial machinery, laboratory and medical equipment, and other sensitive equipment. Step-down transformers. Step-down transformers have a turns ratio of less than 1, which means that the primary winding has more turns. These transformers convert the high voltage and low current input from the primary winding to a low voltage and high current output on the secondary winding. In the electricity distribution, the step-up transformers are situated in the power generating station while the step-down transformers are installed in the substations. Step-up transformers. Step-up transformers have a turns ratio greater than 1, which means that the secondary winding has more turns. These transformers convert the low voltage and high current input from the primary winding to a high voltage and low current output on the secondary winding. Single-phase transformers. Single-phase transformers consist of a single pair of windings arranged in a core and generate a single alternating voltage which is represented by a single sine wave. They have 4 terminals. Each winding has 2 terminals. No star, Y, or delta connections are present in this type of transformer. Single-phase transformers have a simple construction and are used in residential and light commercial power supply. They are more popular in rural areas where the demand for electrical power is low, making a single-phase transformer the most cost-effective option. Three-phase transformer. Three-phase transformers are composed of 3 pairs of primary and secondary windings. They can be constructed by connecting 3 single-phase transformers to form a transformer bank or by assembling 3 pairs of windings into a single laminated core. Three-phase transformers generate 3-phase alternating current flowing in separate conductors. 3 sine waves represent this, and the waves are separated by 120 degrees from one another. The amplitude is reached more frequently, which makes 3-phase transformers supply power at an almost constant rate. The windings of the primary and secondary sides are linked in either delta or star connections. The primary and secondary windings can either have the same or different connections. Hence, several 3-phase transformer configurations are possible. star-star connection, star-delta connection, delta-star connection, delta-delta connection, open delta connection, Scotty connection, high-leg delta connection, star-star, delta-delta, star-delta, delta-star connections. Three-phase transformers are popular due to their efficiency in heavy-duty applications since they effectively utilize winding connections. They are used in large motors, electric power distribution grids, and other large loads. They are also less expensive than three single-phase transformers which provide the same volt-ampere rating. Aircore Transformers. Aircore transformers have no physical transformer core. Their primary and secondary windings are wound in a solid insulating material. They are used in transmitting radio frequency currents. Ferrite core transformers. Ferrite core transformers have a ferrite core. Ferrites are ceramic, which is made up of iron oxides, zinc, nickel, and manganese. The commonly used ferrites in transformers are manganese zinc ferrite and nickel zinc ferrite. Ferrites have high magnetic permeability, the property of a material to allow magnetic flux to flow through it. They also have high current resistivity and low eddy current losses for a wide frequency range, making them ideal for high-frequency applications. Ferrite core transformers are widely used in wideband transformers and electronics applications. Iron core transformers. Iron core transformers possess an electromagnetic core made up of laminated iron sheets. They are the most common type of transformer under this category. Iron cores have high flux linkage, which is attributed to their excellent magnetic properties. Toroidal core transformers. Toroidal core transformers are transformers with torus or donut-shaped cores made from iron or ferrite. Their primary and secondary windings are wound on the toroidal core. Due to their ring shape, their toroidal cores have low magnetic flux leakage and high inductance and Q factors. Hence, their efficiency is high. Toroidal core transformers are used in telecommunications, power distribution, and industrial control systems.